we are going to take a break from graphing, and we're going to step into completing the square. And that is trying to make perfect square trinomials. So I want to review with you what that is, what it means. So remember, a perfect square trinomial, I would ask myself, is this a perfect square? Yes. Is this a perfect square? Yes. Is B 2 times the square root of the A term times the square root of the C term? Is that 2 times 1 times 5? Yes. This would be a perfect square trinomial. We did that in the other unit. I'm going to do the same thing here. Is this a perfect square? Yeah. Is 49 a perfect square? Yes. 7 times 7. Is 28 equal to 2 times the square root of A times the square root of C? 2 times 4 times 7. Whoops. 2, the square root of 4 is not 4. It would be 2. 4 times 7 is 28. So yes, we have another perfect square trinomial. And for the last one, is this a perfect square? Yes. Is this one a perfect square? Whoops-a-daisy. 9 is a perfect square. Is 30 2 times the square root of the A term times the square root of the C term? 2 times 5 times 3. 15 times 2 is 30. So we have a perfect square trinomial. Now, thinking back, we first figured out we had perfect square trinomials. Factoring them should be pretty straightforward. You will take the square root of the A term, so I would have x. Take the square root of the C term, which is 5, and then the sign that's in front of B. So it would be x plus 5 squared, or you could say x plus 5 times x plus 5. For the next one, I will take the square root of the A term, so that would be 2x. The square root of the C term, which is 7. Sign in front of B, squared. So if I FOILed that back out, 2x plus 7 times 2x plus 7, I would get that answer. Following the same thing we were just doing, square root of the A term, square root of the C term, sign in front of B, squared. 5x minus 3 squared. Those are all perfect square trinomials. Now, a couple things we are going to do is we're going to look at this first one. And I'm going to go into a lot of detail with this first one. But I wonder, excuse me, do I have, set it equal to 0. So I would minus 5, x squared plus 6x plus 4 equals 0. Then the A term is 1. So I want to find numbers that add to 6 but multiply to 4. Oh, I don't know of any. Up until this day, we could write the word prime. Prime will not be part of our vocabulary anymore. You should not have any prime solutions as we continue forward. What we're going to do next is I'm just going to rewrite the math problem here. Do we have a perfect square trinomial? Is that a perfect square? Yes. Is 9 a perfect square? Yes. Is 6 2 times the square root of the a term times the square root of the c term? Yes. In factored form, then, we would have x plus 3 squared, and it would still equal 5. I need to solve this. What I can do, we talked about the square root property just a little bit in the last unit. I'm going to take the square root of both sides. That would leave me with x plus 3 equals positive square root of 5, and x plus 3 equals negative square root of 5. So I would subtract 3 from both sides and subtract 3 from both sides. And then you will use your calculator and come up with answers to the nearest tenth. So I'm going to do negative 3 plus square root of 5, and I get negative 8/10. Then I will go up and do negative 3 minus the square root of 5, and I get negative 5 2/10. These would be on my graph now where the parabola would cross the x-intercepts before we call it prime because we didn't know how to factor it. Now we're going to use the perfect square trinomial square root property and solve some of these. We'll do another one together. Okay, before I move the 11 over, I am going to ask myself, is that a perfect square? It is. Is that a perfect square? Yes. Is 14 2 times the square root of the a term times the square root of the c term? 2 times 1 times 7 definitely is 14. So instead of bringing the 11 over, I can factor this square root of the a term, square root of the c term, sign in front of b, equals 11. Then, thinking back on our square root property, I would take the square root of both sides. X minus 7 equals the positive square root of 11. X minus 7 equals the negative square root of 11. Add 7 to both sides. And then you definitely will need your calculator because the square root of 11 is not a perfect square. So 7 plus the square root of 11, I get 10.3. Now I need to subtract 7 minus the square root of 11, and I get 3.7. Those are my roots, my x-intercepts. Now we can't say prime. Back in the day we would have because they are decimal answers. I went pretty fast. Pause the video and please do the next one by yourself. Pause the video. Thank you for pausing the video and giving it a whirl. Perfect square trinomial, x plus 8 squared equals 40. Take the square root of both sides. Subtract 8 from both sides. I end with x-intercepts, roots of those two irrational numbers.